Hello everyone. So already in my previous videos, I have demonstrated how to design a microchip patch antenna, and you can see my first video, which is all about the rectangular microchip patch antenna, which you can see on the screen. And also in my second video, I have demonstrated how to design my circular patch antenna. Now here we will discuss an important concept that is called as DGS. DGS nothing is nothing but defected ground structure. If the ground plane is modified, then you can tell that this DGS will exist. Suppose if you are modifying the ground plane, then the DGS will exist. The DGS will come to play. So here you can see this is the ground plane. You can see in dark brown color. This is called as the ground plane. If I modify this one, then it will be called as DGS. So here, let me demonstrate you how to do a simple modification, and then how the results will vary. So here you can see the results. This is the S parameter. Okay, here you can see it is resonating at 2.24 gigahertz, and the value is around minus 12.9 dB. Okay, so let us simulate again. The results may vary, so let us do the simulation. And after simulating you will get a result of a microstrip patch antenna without DGS. Then we will simulate and we will see whether this particular microstrip patch antenna is resonating at the desired frequency or not. So already the simulation is over. Now we will see how the results will come. So again let me see. So this is the result which came after simulation. So here you can see this was the previous result. So let me discard this one. Let me keep this particular result. So this is the result which you can see. So if I add a marker here, then you can see that it is resonating at 2.3680 gigahertz, and it is resonating at minus, and the S11 or the reflection coefficient is coming at minus 20 dB. Okay, so this is basically the microchip patch antenna without any slot or without any DGS. Okay, you can see here I have renamed this as without slot. So let me rename as without DGS. So simply I can rename as microchip patch antenna MPA. So this is the original MPA which you can see. Now this one only you can copy, and here you can paste. So another file will be created. Okay, no need to do the design. If you want to do the microchip patch antenna design, I will give all the details and the link of my first video where the step by step approach has been demonstrated. I will give the link in the description box. Now this one will implement using DGS. So I can write microchip patch antenna with DGS, defected ground structure. So this is the microchip patch antenna where we will implement the DGS. So I can orient this like this, and you can zoom also. So you can go to zoom and you can zoom, so there will be a proper view. Now we will implement different type of DGS. Okay, so let us implement a H-shaped DGS. Simple DGS also you can implement, and let us implement a H-shaped DGS. So this is the ground plane. You can see the cursor, and the ground plane is visible with dark brown color. So I can now modify this ground plane to a H-shaped DGS. So I can draw. So this point, you can observe this particular point. This one is 0, 0, 0. So I can draw a H-shaped DGS like this. You can draw a box. Then X is -2, or you can take X is minus, suppose say 8 if you want a bigger slot in the ground plane. So I can take -8. Y is, I can also take -4, and Z I can take 0. So here you can see. Then dx I can take, that will be, suppose say 16, because x value we have started from -8, so I can take 16. Dy I can take -2, suppose say, and dz I can take 0.01. So here you can see one box is created, and that is in the same plane as that of the ground plane. So if you click here, then you can see the dimension of the box: -8, -40, 16, -2, 0.01. So you can assign the same material. So here you can write DGS HDGS1, because this is a part of HDGS. So HDGS1 I have written, and you have to assign the same material as that of the ground plane. So I have assigned copper. Okay, so you can click OK. So here you can see this is the radiation box. You can hide it. So here you can see one part of this HDGS has been created. Now second part we will create. Again you draw a box, and then you can give the dimension: x equals to -1, y equals to -4, suppose say, or -5 you can take, and z equals to 0.01, 0, z equals to 0, z equals to 0 only, because the ground plane is at 0. And dx, you can press the tab key, then it will come to the dx. Then dx will be 2, and dy will be, you can take a bigger slot, so you can take, it is 10. Okay, because you have started from 5, so you can take as 10, and then dz 0.01. So this is the second part of the H you have considered. Okay, so this is basically the second part of this H DGS. So here I have to make it uh, H DGS 2, and material assigned copper. Okay, then this HDGS again I can duplicate, edit, duplicate along the line. So this operation, all of you please remember, this is a very important operation. If you want to create similar type of structure again and again, no need to draw again and again, you can duplicate. So how can you duplicate HDGS? You can go for this first part. Okay, the left hand side part, you can tell, click on that HDGS1, edit, duplicate along the line. So this line you have to duplicate. So here you can see there will be a triangle, and here again you come to the origin. Okay, there will be a triangle. So again you have to come to this origin. So you have to write this one as dx equals to 0, dy equals to 6, and dz equals to 0, and you press enter, and here it will show total number is 2, then press enter. So here you can see it is duplicated. Okay, but this particular H-shaped DGS we want to align symmetrically. H-shaped DGS is created, but it is not symmetrical. Okay, so again we have to change the dimension of this. So click on this duplicate. So y you can take is 10. So let us see. Now it is perfectly all right. So here you have to duplicate, and the vector means the distance vector is 0, 10, 0. So this is the H-shaped DGS which has been created. Now this H you create click, then press Control, then again click this one, then again you click this one, right click, edit, boolean, unite. So you can see a complete H-shaped DGS has been created. Now click on the ground, click on the HDGS, right click, edit, boolean, subtract, blank part ground, tool part HDGS. So it has been subtracted. So here you can see one H-shaped DGS has been created. Now let us see what kind of variation is happening if we are considering the results, particularly as parameter. Obviously here you can see if a ground plane is sorted, then if you convert this to a circuit model, then you can observe one extra capacitance can be added. So obviously if one extra element is added, then the resonant frequency will shift, as well as the bandwidth will be varied. So let us see. So here you can click HFSS, validation check, then HFSS, analyze all. So previously you can see you have seen the normal microstrip patch antenna, or you can tell rectangular microstrip patch antenna without any DGS. But here we have made the DGS and we have simulated the antenna. And one another thing I want to tell, that if a particular requirement is there, then only we have to go for the DGS. So if we want to increase the bandwidth, or if we want to increase antenna gain in some scenario, then we can go for DGS. Otherwise, we can go for any other parameter or any other modifications. So here you can see the simulation is going on. So based upon the simulation, after the simulation, we can tell that what kind of variation is there. Previously, I have shown microstrip patch antenna without any DGS, and already we have the results. Now let us see what type of variation is happening. So this is the microstrip patch antenna without DGS. So this is the result. Okay. So let us see whether the resonant is frequency is shifting or not, and any change in the bandwidth. So here the bandwidth the varies from the range of the frequency is, so here you can see the range is 2.3350 to 2.3955. So 0. 0.06 gigahertz. So around 600 megahertz like that. It is happening. Sorry, it's, 0.06. So around 60 megahertz like that the bandwidth is coming. So let us see whether you will get a larger bandwidth or will get a variation in the resonant frequency. After the simulation it will be there. Okay. So here you can see 0.06 gigahertz bandwidth is there. So around 0.06 into 1000. So that will be around 60 megahertz. So 60 megahertz bandwidth is, which is very very less. So we have to increase the bandwidth so we can go for this DGS. So this is the DGS. Let us see what type of results we are getting. So simulation is over. Now let us see what type of results we are getting. So you can go to the results. Already I have shown this as parameter. So here you can see it is completely different now. So you can go for the results, model solution and new report. Okay. So let me verify whether this is, yeah, MPA with DGS. So here you can see the S parameter is completely varied. Now it is resonating at 3.5 gigahertz. Okay. So what you can do now is, all of you please see this one you can copy. So you click on this particular figure, then copy data, and here you can paste it, the previous figure which is without DGS. Then if you click, then you can see a detailed comparison. Okay, you can see a detailed comparison here. So this green one is with DGS, the red one is without DGS. So here you can delete all the markers so that it will be properly visible. Then you can add. Okay. So if you have deleted all the markers, then the graph is properly visible. You can rename this graph comparison of S parameters. S parameter. So this is the graph. So this green one is with DGS and the red one is without DGS. So here you can add a note also. So you can right click and go for the add a note, and here you can write without DGS. So this one is without DGS. You can drag here, and this red line is without DGS, and this green line is with DGS. So here you can keep. So this green line is with DGS. Okay. So this is how you can plot these two graphs. So here you can see the change is visible. Okay, the shift of the resonant frequency is visible. Okay, so this is all about this microstrip patch antenna with DGS. Okay, so this variation you can also see in the radiation pattern. Okay, so for the time being we'll concentrate on the S parameter. Thank you.